Hey everyone, we are back for lesson 11 here, almost done with chemistry and the year. I'm recording this on June 1st. I don't know when you'll get it later in June, but the year is wrapping up. So today we're going to look at how atoms combine. And so we know that atoms combine with each other and they form new things. So when hydrogen and oxygen bond with each other in a 2-to-1 ratio, we get water. When in a 1-to-1 ratio, when we get sodium and chlorine bonding to each other, we get sodium chloride, and the new substance is table salt. So today I'm going to go over different methods of combining and how we name these elements. So first of all, metals. Metals do not bond with other metals. They form solutions, and we call these alloys. So you're not going to get a gold atom and a silver atom bonding with each other and creating something new. You're not going to get zinc and sodium bonding with each other and you get something new. There'll be no chemical reaction. So metals just form solutions, and we call those solutions alloys. Now, last day I started talking about ionic bonding, and that's between metals and non-metals. So this is when we have one metal and one non-metal, or bonding with each other, and they form what's called an ionic compound. So I talked about this last day. Atoms want to have a full outer orbit. And in the case of, say, alkali metals that only have one electron in its outer orbit, it wants to lose that one electron to get down to a full outer orbit. And it'll lose that one electron very fast. That's why alkali metals are so reactive. They all have one in their outer orbit, and they can all lose that one very quickly. Likewise with chlorine in the halogen family, it has 7 out of 8. It wants to get one more to have a full outer orbit. And since it's easy to get just one, halogens are very reactive. Now, when an electron jumps from the sodium to the chlorine, the sodium then has one less electron than proton. It becomes positively charged by 1. And when that chlorine gets an extra electron, it gets a -1 charge because it has one more electron than proton. And so because of that, what happens is because there's a positive and a negative ion. An ion, of course, is just an atom with a charge. When you have a positive and a negative, they attract to each other. And when they attract to each other, we get a reaction and we get something new. So naming ionic compounds. The first part of the name always identifies the metal cation. Cation is a positive ion, and it's just the name of the metal. The second part of the name always identifies the non-metal anion, and the name of the non-metal ion always ends with the suffix IDE. So you can see in the examples I have here, calcium and nitrogen, it would become calcium, the metal first, and nitrogen, the non-metal, comes second, and you change the ending to IDE, so it becomes calcium nitride. Lithium and oxygen, lithium comes first, the metal, oxygen changes to oxide. The sodium and the chlorine becomes sodium chloride. Magnesium and oxygen, magnesium oxide. So it's just as simple as that. And I'll likely do a little video for you to show you how these things bond and to go over the naming with you. Now, nonmetals will also bond with nonmetals. So we have metal and metal do not bond, they form alloys. We have metals and nonmetals forming ionic bonds, and nonmetals and nonmetals combine, but no ions are formed. They don't lose or gain electrons, but they share them. In this case, I like the term sharing is caring. So we call these bonds either covalent or molecular bonds. And depending on which textbook you're using or what resource you're using, you may see it as molecular or covalent. So this is a bond when two nonmetals share electrons. So we have two chlorine atoms. And we know chlorine is one of our diatomic molecules. In nature, chlorine will never be found on its own. It's always found joined with another chlorine. And so chlorine has 17 electrons, 2 in the first orbit, 8 in the next, and 7 in its outer orbit. And it's family 7. So just going back to our periodic table, remember when I had you label the tops as families 1, 2, 3, 4, 5, 6, 7, and 8? Those numbers also correspond to how many electrons are in its outer orbit. So chlorine has 7 out of 8. This chlorine atom here is not happy. It wants 8 out of 8. And this chlorine atom has 7 out of 8 in its outer orbit. It's not happy. It wants an 8th one as well. So what happens is non-metals will bond this way, covalently or molecularly. And you can see here that they actually share electrons. So we now have 8 in this outer orbit and 8 in this outer orbit, which makes both of these atoms happy. And in reality, what's happening is they are sharing these electrons here. Here's water, same thing. Hydrogen has 1 out of 2 in its outer orbit. This hydrogen has 1 out of 2. And oxygen in its outer orbit, the first orbit's not shown here, but oxygen has 6 out of 8. And so what happens is it bonds together like this. And you can see this being color coordinated actually shows it a little bit better. So hydrogen now has 2 out of 2. This hydrogen has 2 out of 2 in its outer orbit. And oxygen has 8 out of 8 in its outer orbit. And it's because they are sharing these outer orbit electrons. And so we get the water molecule. And so that is that. Perhaps I'll do a little video and show you how to draw these up and go over some of the naming with you as well.